This is Chapter 5, Part 2, and this is about the MAC address. When we look at the MAC address, it is what we see is the hexadecimal numbers. And that is because, as I said earlier, the MAC address is altogether 48-bit long. But 48 zeros and 1 does not make sense to us humans. So that is why we will give it to you in hexadecimal numbers instead. And the thing with the hexadecimal numbers, it is that it is the 16 based numbering system. So we have 16 digits altogether from 0 to 9, and then we use the letters A, B, C, D, E, and F. The connection between the hexadecimal number and the binary numbers are that one binary number, or four binary numbers equals one hexadecimal number. So that is why instead of writing 4 zeros and 1, we can just write one hexadecimal number instead. And we will learn how to convert from hexadecimal to binary numbers. But when you look at your MAC address, if you do an ipconfig/all, you will see it as the physical address. And this is just a number. You will be able to see what kind of vendor that has produced your NIC, your network interface cards. But that's the only thing that you can actually see from it. It can either be put in here like with dashes between the numbers, or with colons, or with periods, depending on how they are represented. When we have a MAC address, as I said on the local area network, we are always just sending to and from the MAC address. Typically, we are also given an IP address. And when I send something, in this case here, from the computer to the server, the source and destination IP will of course be put on, but also the source and destination MAC address. And this is called a unicast communication when I send from one to all. So then we just need to know which MAC address is sending and which MAC address will be receiving the data. Sometimes I also need to send out to all, and this could also be done on the MAC level. The destination MAC address then are the highest value, the highest overall value of the 48-bit, and that is all ones. And if then that is converted into hexadecimal numbers, it contains only of F, since F is the highest value. So here, this is a broadcast MAC address, which means that all devices on the network will then receive this packet. And we also have multicast addresses. Multicast addresses are like a group mail address. So you can have devices that belongs to a multicast group. And of course here as well we have a multicast address for that on the MAC level. Same, we will also have that on the IP level. The MAC address does not change. It is similar to the name or a person. It doesn't change what kind of network that we connect to. We will still have the same MAC address. The same applies to us. If I move from one address to another, I will still keep my name, probably. And it's also called the physical address because it's physically assigned to the network interface card. The IP address is similar as the address of a person. That is based on where you actually live or where the host is located. So when you move from network to network, your IP address will change. It is the logical address because it's assigned logically, and it's assigned to you by either some automatic setup or by the network administrator. Yeah. So when we send something, the MAC address and the Ethernet address, the IP address is put into the different layers. So here we have the MAC address on the data link layer, where we have the destination MAC and the source MAC. And then of course also on the network layer we have the source IP and the destination IP. When this package is received by the router, it will look at the IP address and see which network do I need to send this to. So typically when I want to send something out on my own network, I need to have IP addresses on it, because the IP addresses is used to differentiate between the different networks. The MAC address or the frame here cannot see it. So what we will see is that the MAC address of the packet could actually change from different networks, because this here, it's sent out on an Ethernet, and then we have one type of a frame with the MAC address, but then the router will encapsulate it into another type of layer 2 frame. If you want to, for instance, send it by satellite, then there are an entirely different protocol that applies here. And up in the satellite, it will also change again, and when it's received by the end receiver here, and it's a wireless network, it can also be changed again. But the IP address will probably be the same all the way through, so that we will know where to send it. And that was a little bit about the MAC address.